So you think it's fine? You're laughing.
Everybody up. Up, up, up. Everybody up. Get up. We are playing a game. Everybody ready? Heads or tails? Ready? Heads or tails? Everybody got them? Heads.
Whoa, we got a cheater in the back.
What do we have left? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
That was like 50. That was 50%.
150?
No, we're just playing a game. Everybody got it? Tails.
Lucky guys.
2, 3, 4, 5, 6. We're down to 9. All right. Everybody ready? Head. Oh, sorry, tails.
Okay, where do you go?
Are you ready?
He's undecisive.
Yeah, I think there's one by the mall.
What is that?
Heads.
Oh, he does.
Down to 3. Ready?
You guys pick your winner. Cole.
Tails.
I'll pick.
All right, let's go.
Cole. I got one. Yeah,
He's
Cole.
not like problem.
Ready?
No, I have.
Oh, this will be good.
Heads.
Tails.
I'm big.
Stay up.
Silent set.
Ready?
He's like bragging rights.
Oh, we're still going. Heads.
Alright, scary.
Oh, heads. I like the heads. Especially I got heads.
Heads.
That's impressive.
Okay. So, based on this model, is this growth or decay? Decay. Why? Because it goes down. So here's what I want you to do. In your calculators, I want you to put these numbers in. Do not put the first one in. Do not put the second one in. So put the rounds in list 1. Put the number of people that were still up in list 2. Okay, so you have that. So if you go stat, over to calculate, and I'm going to cheat and go up instead of down. And I'm going to go to this exponential regression. Hit enter. Hit calculate. And you should have this. What's my exponential model? Y equals we'll go 707 for 3 decimal places, times 630 to the x. Yep. No, you don't need that. You just need the A and B. Okay. What does the A represent? What? The starting value. I had all of you stand up at the beginning. So after 0 flips, there were 21 of you. This number is awful close to 21. Right? What does my base represent? What's that? Not how much that are at the end, but after each flip. So basically, this says that after 1 flip, 63% of you are going to sit. And then after the next flip, 63% of whoever is left is going to sit. Okay? So in terms of the problem, okay, if I were to model the exact problem and come up with my exact equation, what would this starting number be? 21. What should this multiplier be? 0.5, right? Because if I flip a coin, I assume that half of you are heads and half of you are tails, and whatever comes up, half of you are going to set. Right? Okay. In your list, go back to your list, and at the very bottom, put in 0, put in 21. And run the regression again and tell me what comes out. What came out? What? If you put 0 in and 21.
But not the 8.
But not the 8. No, don't put that one in yet.
20.829.
20.829 and 0.629. So about the same, right? Now, throw this last number in. What comes out? An error. Why? Has to be greater than 0. The range of my exponential functions. All of my exponential functions have to have a range greater than 0. So technically it can't go all the way down to 0. So according to my game, I can keep flipping until the last one goes down. But according to the model, our model for this would be that, right? Am I ever going to get to where everybody is down in there? No. can I change this problem with the data that we have to be a growth model instead of a decay model? How? I have to have it greater than 1, but what do I want to look at? Not bottom to top, but what did I track to begin with? Well, kind of the inverse. What did I track? How many people sat? Or were still up, right? So what if I track the number of people that are down? So, if I don't flip at all, how many people are down? Nobody is down. After one flip, 12 were up, so 9 were down. After 2, if 9 were down, 12 were, or 9 were up, 12 were down. After 3, 15. After 4, 18. After 5, 19. After 6, 20, 7, 20, 8, 21. One through 7. Keep your numbers 1 through 7 and change your Y values to those.
How do you get it back?
How do you get it back? Awesome.
Yeah.
Oh, go stat. Go down to setup editor. And then hit enter, and that's what will come up on your screen. And then you need to type in list 1, comma, list 2. So second one. And then your commas above the 7.
I just said no.
Oh, you have to go to setup editor. Go to that again.
Guess what 5 is?
And then type in L1, comma, L2, go all the way to L6. Yep, second 2, comma, second 3. Is this what you came up with?
Yes.
9.237 times 1.139 to the X.
Why?
Okay. Go in and add the last point. Go in and add this 821. comes out.
Got all of them good.
Okay. Go ahead at this point.
It's in.
Oh, I think you're wrong. So I
What happens? Error. Why? Because x can't be 0. Think about this. This number in front represents what? My start. Why can my start not be 0? It's always 0. If my starting point is at 0, 0 times whatever this is always going to be 0. So I can't have 0 as a starting point. So it makes sense when we play heads or tails to have nobody sitting down. But it's not going to make sense for me to come up with some kind of a model. Now, after that first trip, what happens? How many people did we have sitting down right away? 9. Okay? So this starting number should be close to the number that we had sitting to begin with. So if I were to do this, and try and get true results out of it, I would have everybody stand up and I would make one sit down. So for example, now that we've already done it, I say to Cole, you can't play because you won the last time and you can't win again. So now I start with 1 down. So at 0 I would have a number here. And then my starting point over here would now be at 20. So when you go in and you look at these formulas that they give you in the book, okay? These are the formulas that they give you in the book. What does that represent? What you start with. What does this represent? How many times you've done it. What does this represent? The rate at which you are getting people to go down or come up. Okay? If you are in a situation where you're dealing with the natural base, what does that number represent? What you start with. What does this number represent? How many times? What does this represent? Your rate. Your K is your growth or decay constant. Or it's going to decrease at a particular rate all the time. It's going to increase at a particular rate all the time. I don't know why they use K to represent a constant, but basically I would use R because that's your rate. Okay? So here's my question. Oh, and I erased the table. So down there we had what? 6 was at 19. 7 was at, 8 was finally 21. So this was 20, this was 20. And 5 was at 19, right? Okay. And our model was 9.7 something, 1.11 to the x. What happens if I put 100 in for x? So whatever your model was here at the very end, Put 100 in for X and tell me what happens. Give me the value. What is it? Well, it's big, but what is it? About 1,000?
No, it's 68. 680.
680? Oh, yeah, yeah. Okay, 680. So now put in 200. What happens there? So if you take your 9 whatever times 1.11 to the 200, what comes out? $1.133 times 10 to the 10. Now think about that. That is a lot. Does it make sense? Does it make sense that the number of people that I'm going to have sitting down would get that big? In this room? No. So, I'm going to let you people in on a little secret. Okay? The reason, now this was the big decision whether to join the Valley or stay in the Womack. That big decision, the reason that they wish that they would have put it off for a few more years is this. The state of Iowa has been waiting to see, they've applied. There's a national study that's going on right now, and they're looking at taking all of the athletics out of the high schools and leaving it to all the clubs. So like AAU basketball, USVBA volleyball, the athletic congress for track and field. Taking all of the athletics out because it's going to save money on the schools. It's going to be a money saving thing. Okay? Iowa has petitioned to be the state to pilot this. So it's not going to make any difference if we go to the Valley if we're going to end up piloting it and the schools aren't going to have anything to do with it anyway. Okay? So now, I've started this rumor and I've told you 21 people. Okay? Does it make sense that that rumor is going to continue and go on and on and on and just find fill to as many people as possible to get into the billions? No. It's never going to just keep getting bigger and bigger and bigger and go without bound. So, at time equals 0, I've told 21 of you. Okay? None of you can keep your mouth shut. So after 5 hours, this rumor that I've started has grown to 700 people. Social media. After 7 hours, the rumor has spread to 900 people. Put these 3 numbers in your calculator. Okay? You all know how to clear lists out? If you go stat edit, and I'm going to go up to the top of this, and I'm going to highlight the list and just hit clear and go down. What's that? Sure, we're going to take everything out of the school. When? Yes, I told them I was leaving for the AEA before Snyder cried. What? No, that was true. Selective hearing. She did not hear the part where I said I was going to start a rumor. 21. Heard it, and then 700. And then 900. Okay, so you've all heard about exponential growth and decay. You would have done that in Algebra 2. And the problem with exponential growth is it doesn't make sense for that value just to keep getting bigger and bigger and bigger and never stop. So if you go into Stat and over to Calculate, and if you go up, this says Logistic. That's what you want to run. Okay? And this is your equation. So, y equals c over 1 plus a e to the negative b x. So, do you all have this up on your calculator? Okay, I'm going to show you what to push, because we're going to play with this a little bit. Go to y equals. Make sure that you have nothing in here. So if you have something in there, clear it out. Okay. Bars. Go down here to number 5 where it says statistics. Move over to EQ. And where it says regression equation, hit enter. And what it's going to do is it's going to plug that in for me. The next thing that I'm going to help you with, window. I want x to go from 0 to, oh, we'll leave it at, let's go to 15. Up there. It goes 0 to 15. And then on y, 0 to 1,000 by 100. Okay? And then graph it. So this is what your logistic curve looks like. Okay. What happens in the graph? It goes up and flattens off. Trace it and tell me where it starts to flatten off. So go all the way over and start looking at your y values. 950, 940s, 950, 944-ish. Where does that number show up in the equation?
Oh, it's right there. That's weird. I'm curious, what?
Where does the where this flattens off up here? Where does that number show up in the equation? In the numerator. What do you think in terms of my little rumor problem? What do you think that number represents? Say it, Luke. Total number of people that are going to find out my rumor. What's the population of the students at Western Dubuque High School right now? Like about that many. About that. So, the top, in your logistic curve, the top number is your population. Okay? In the equation, this 1 is always going to be here. Okay? Okay. How do I find out how many people I told right out of the gate? Even though you know it was the 21 of you. How would I find it? Say? Yeah. Put 0 in for x. So follow this. If I put 0 in for x, what does this come out to be in the exponent? 0. Right? Anything to the 0 power is 1. So I have 1 plus this number. Right? So my initial value, I basically ignore this. So do you agree that's 45.035? Take this divided by 45.035 and tell me what comes out. Or trace and put 0 in on your graph, yes. 20.999. How many people did I tell my rumor to out of the gate? 21. So the way that they get B, you have your total population. So your population divided by 1 plus B has to equal your initial audience. Okay? So I always have 1 in that lead spot in the denominator, and it's always 1 plus something. The way that I come up with that is it's my total population divided by 1 plus my initial audience. What does this represent? Not the total capacity is the total population at the time. Not the time, the rate. This is the rate at which my rumor spreads. But here's my question. I tell you, you go and spread it throughout social media, and then after 5 hours we get to 700 people, and then after 7 hours we get to 900. Is that growth or decay? Growth. What's my exponent? Or what's my rate? Negative. And negative usually represents what? Decay. Yeah. But think about this. Ah! You're dividing. How do negative exponents behave? If I come up, now what is that? Now it's positive, so now it's growing. What does X represent?
Hours.
How many hours? So whatever my time is. So if I were to give you a story problem, because you all freaked out when you saw this, C over 1 plus A e to the negative bx, and it gave you all that stuff, and you were all freaking out because of the problem, or because of the way that that equation looked. But if you think about it, if I gave you a story problem, I could tell you the population that I was looking at. I could tell you how many people I told the rumor to. And I could tell you after a certain amount of time how many people had heard it. And then based off of that, you could solve that to find out how fast, what your rate is. Because I've only got one variable left. The logistic curve makes more sense because think about all of your exponential growth problems. Your exponential growth problems, I have some population in a city. Sooner or later, that population has to level off. You can't just keep bringing in more and more and more people. Deer population. Why do they let people hunt deer in the fall and in the winter? Because the deer population is getting so big it can't be sustained. So they kill some off. Okay? So, I'm going to give you a problem to think about. I don't need an answer until at the end of the unit. Okay? I'm going to say that you are somewhat normal. You don't keep your house too hot or you don't keep it too cold. I go over to the sink, I throw in a bunch of water in the morning, I set this pan of water on the stove and just leave it there. Don't turn anything on. You agree that by the end of the day, the temperature of the water is probably going to be at room temperature. And I'm going to assume that that's 68. Okay? Does your water, once I turn the stove on, does that water continue to get hotter and hotter and hotter and hotter? It does until what? Starts to boil. What's the boiling temperature of water? 212. That's what your model looks like when you turn on the stove and boil water. You turn it on and it's real, real cool, and then it heats up real hot in a hurry, and then it starts to boil. And then after a while, I get tired of watching this water boil, and what do? I turn it off, and I let it set. And it comes back down to room temperature. Those of you in cooking, or cook a lot, about how long does it take water to boil? We'll say average. Just an average. I have like a big, so I'm cooking spaghetti and I've got a big spaghetti pot. So what is that? 2 quarts. 2 quarts. How much? Okay, we'll say 10. Average people, normal people. I'm not normal. I make like a huge pot. When I was single, I would make a big thing of spaghetti on Sunday night, and that would be supper for the week. Okay? So you go in, you turn this on, and after 10 minutes, it starts to boil. Now think about this. You go down to Rose's room and you get hot chocolate in the morning, and when they dump it, it's ungodly hot, almost to the point of boiling, right? Or you're at home and you have a little Swiss Miss because you have to have your little marshmallows and you pour that in. You pour the hot water in when it's boiling. What happens to it? You can't drink it right out of the gate. You have to let it sit for a while, but during that while, it's really, really hot, and it's really, really hot, and then all of a sudden it doesn't take very long to cool it down. So cooling works the same as heating. But when that hot chocolate cools down, sooner or later it's got to level off at some point. It's not going to continue to get colder and colder and colder and colder. Right? Story, problem, applications of log and exponential functions.
Oh, God.
You're done. Now, well, think about this. There are other applications, but what do the other applications use? The same types of formulas. right? If you're a banker and you're looking at compound interest, it's the same thing. What's that first number? It's your initial amount. What's your R? It's whatever your interest rate is. What's your N? It's the number of times they compound it. What's your T? It's the number of years it's in. It isn't any different than the equations that we had up on the board before. So you can do assignment, what are we up to now? 4? Assignment 4 for tomorrow.